We will now discuss the important topic of dependency injection and its relation to Magento's Object Manager. Dependency injection is a way to retrieve objects. In this process, classes receive objects they depend on as constructor arguments. In Magento 2, the Object Manager is responsible for creating all objects a class requires. You define your class with the constructor receiving the argument objects that it needs. The dependency injection system, basically the Object Manager, will create them for you. All this is based on configuration. Dependency injection is a complex topic which may be new to you. Do not worry if you do not immediately absorb all of the concepts presented in this module. We will use dependency injection throughout the course in many of your exercises, and each time you work with the concept, you will build your knowledge and confidence.
Dependency injection is configuration that is XML-based and validated by XSD. Magento 2 uses dependency injection as a class instantiation mechanism. Assume you need a store manager instance in your product class. You can declare an argument with the type store manager interface in the constructor of the product. Now, using di.xml, you have to define which class will be substituted for that interface. For that, you have two options. Define a preference and it will work globally, which means that every other class that declares an argument with the type store manager interface will receive what you defined as the preference. Assign a class in your di.xml for this particular object, product, and the preference will not be global, but only apply to product.
See your course exercises guide for instructions on how to complete this exercise and the solution. This diagram shows how classes are typically instantiated in Magento. The constructor original class is key. It contains a list of declarations, dependencies, that could be other classes, interfaces, factories, and others. When the original class is instantiated somewhere in the request processing flow, the DI mechanism reads its constructor and instantiates dependencies based on the configuration in the merged di.xml file. This is a very powerful construction. A developer can declare a di.xml and change something in another module, for example, adding an element to an array in the constructor of another class.
Of course, the best candidate to use with DI is a singleton-type class. By singleton-type class, we mean a system class that usually exists in a single instance and is used in different places in the code. Examples could be cache, session, registry, helpers, and other classes. Note that factory or API class also matches this definition. It is important to understand that not every class has to be injected using dependency injection. For example, so-called entity classes like product. Which product to use really depends on the data in the database. For these classes, it is recommended to use factories for injecting. For example, if you want to instantiate and then load the Magento Catalog Model Product class, you would include a factory in the constructor, create a product instance using the factory, and then load it, as shown on your screen. This example demonstrates a best practice for Magento to use API interfaces for CRUD operations. We will discuss these more in Unit 5. Another important note, the factory class may not exist. When the DI mechanism identifies a class ending with factory among the parameters, and this class does not exist, it will generate such a class in the generation folder. For example, it would be generation, Magento, catalog, model, productfactory.php with the create method.
Now let's talk about how Magento 2 instantiates objects. This involves the discussion of object management, dependency injection, and plugins, as they are all a part of the same system. This is the biggest change in Magento 2 and resolves some of the issues encountered with instantiation of parameters. The new approach makes it much easier to make customizations. In Magento 2, the Object Manager has replaced the Mage class. The Object Manager is the class that creates all objects and is responsible for instantiation. Generally, the creation of an object is one of the biggest problems in software development. In Magento 2, the Object Manager has two methods, get and create. The get method will return a singleton object, called a shared instance in Magento 2, from the protected registry, while the create method will create a new instance of the given class. Generally, it is best practice to avoid calling the Object Manager directly. Instead, you should create objects in another way. We will look at this a little later in the unit. The Object Manager is concerned with the arguments that are passed in as a class constructor's parameters. It parses the parameter types and parameter variable names. It uses configuration to resolve which arguments should be used for a given parameter. It creates the required arguments recursively. If you declare your instances to be shared, then it means they will act as singletons. Shared instances can still be modified, but it becomes more difficult with Magento 2. To see examples of get and create methods, please consult your participant guide.
The slide shows an example of direct usage of the Object Manager class. An Object Manager instance allows you to create any other class. For example, Object Manager get Magento Catalog API Product Repository Interface will return the same implementation of Product Repository Interface as you would receive by including it in the constructor. Note that using Object Manager in your code breaks the DI concept. That is why it is not recommended. As discussed earlier, some classes in Magento are auto-generated. Here are some other examples. Interceptor is a class that allows the plugin functionality to work. When you require a class in your constructor and Magento sees it has a registered plugin, Magento will then generate an interceptor with the same methods as the required class, but will call a plugin in that method. Search for interceptors in the Generated folder and take a look at their structure. Note that they are all pretty similar. Interceptors use PHP traits to extend both the abstract interceptor class and the original class. Proxy is a tool that helps with circular dependencies and relates to an internal implementation of how DI works, so you won't have to deal with them directly.
Magento 2 provides a new approach to working with objects. It not only encourages you to use the Object Manager, but also creates an object for you. Now you need to use the real class name, including PHP namespace, when you require an instance of a class. The creation of objects is such an important process that Magento 2 handles it automatically via the Object Manager and class dependencies declared as constructor parameters. The Object Manager creates the objects you need injected into your classes. It will recursively also create any arguments for the objects your object requires. When a developer declares an interface in the constructor, the Object Manager will automatically create the matching implementation for it, so you don't have to use it directly. So, when you create a class and you require an instance of an interface in this class as a parameter for the constructor, that interface is the only dependency your class will have. You may not know what object you are getting for an interface, but if your class is programmed only using the interface, it does not need to know a class definition. Magento 2 uses preferences to define what class will implement the interface. This is a very modern approach for the PHP community, thinking in terms of interfaces and not implementations. You can create a customization that will make Magento use your implementation of an interface and not the native classes. To view the interface preferences for the Object Manager, use the files listed on your screen. To define your own preferences, you will need to define your own DI.XML, your module directory, etc DI.XML, your module directory, etc area name, DI.XML. See your notes area or scroll on your screen for a constructor method signature example.
Magento always uses only one di.xml configuration during any given request. It includes the merged result of the app etc di.xml, each module's etc di.xml file, and the area-specific di.xml files from every module where the area matches the current request area. For example, front-end or admin HTML. You can not only define preferences for interfaces, but also for regular classes. Preferences define which classes will be instantiated for a constructor argument of your class. For example, public, function, construct, Magento, catalog, API, data, product interface, product. If you require this interface in your code, you will get an instance of the class Magento, catalog, model, product because of the configuration displayed on this slide. This configuration is located in the Magento catalog etc di.xml. The global di.xml, app etc di.xml, defines preferences for key Magento classes. In Magento 2, it is a best practice to request only interfaces and not concrete classes. For example, in your code, you would request the Magento framework app response HTTP interface instead of the concrete implementation Magento framework app response HTTP. The global file di.xml contains preferences for key interfaces. There are different types of arguments. In this example, you can see several types: string, array, and object. Di allows you to define which object should be used as an argument when a new instance is created. So, we have a system where something is required, for example an object or interface, in the parameters, without calling the object manager, and Magento delivers the object that implements that interface. In some cases, the object manager will not be able to deliver exactly the required object. For example, when you need a specific product with specific data, the class dependency can only require a generic product object. It can't provide a loaded entity. As a result, this type of object is not injectable. There is no hard distinction between injectables and non-injectables. The question is, how can I require a specific entity? The system allows you to get the objects you want, but for some objects, it does not make sense to have them generated by dependency injection. You will have to get those by the object manager, then load them, and so on. This will be discussed more in the unit about repositories.
A shared object is an analog of a singleton. You may encounter situations where you want to use the same instance of a class within several other classes. In the example on the slide, the instance of Magento Framework Indexer Interface that is injected into Magento Catalog Model Indexer Product Price Processor will not be shared. The argument shared on the argument node is set to false. If it is set to true, the same instance would be injected every time the price processor is instantiated. It is possible to use the shared argument on both types of nodes and argument nodes with the XSI type set to object.
In this video, we will discuss dependency injection. We will explore one of the core modules, for example. So we will take a look into the catalog module. So when we speak about dependency injection, there are few things that we need to know about. There are preference, virtual type, and argument. So let's start with preference. Preference is a declaration in the XML file, which allows to identify what class would correspond to certain interface. So here we can see an example for Magento Catalog API Data Product Interface. Magento will select its implementation, which is Magento Catalog Module Product. This implementation has to implement this interface, otherwise we will face an error. Let's take a look into that interface and its implementation. An interface is in the API Data Product Interface. Here we go. So here we have some interface. It's really an interface. It has no implementation in it. Now we shall take a look into the implementation, which is Magento Catalog Model Product. Let's take a look. Catalog Model Product. Here we go. So Catalog Model Product. Here's the definition. It implements our product interface. So it implements all that methods. So now, anywhere in the code, we may require in our constructor, the interface, and we will receive the preference, which is defined in the XML file. For example, here in the same product model, we require interface of Magento Catalog API product attribute repository interface. You can go back to the XML and search for product attribute repository interface. So now we can figure out which physical class corresponds to this interface, which means anytime when Magento will instantiate instance of a product, it will set instance of that class, as a parameter to a product model which corresponds to this interface. Second thing that we wanted to that we have to know about is virtual class, virtual type. Virtual type is a string or a class which does not exist. Why would we use a virtual type? We can use virtual type in a situation when we want to use certain class with a certain configuration. So for example, in this example we can see here we have a virtual type which is called Magento Catalog Module Session Storage, which will be an instance of Magento Framework Session Storage with the parameter namespace equal to catalog. So Magento will instantiate instance of the storage and set its parameter to catalog. And this object will be placed whenever you require in your constructor instance of Magento Catalog Model Session Storage. So virtual type allows us to configure special classes and give them other names that we can use in our classes, in our constructors of our classes. This is very powerful and useful technique. The next customization, the next ability and ability to customize and the power of DI that we're going to discuss is argument. So let's take a look into argument. Argument can be property of regular type or a virtual type. So argument defines actually what would be passed as a object argument in constructor. Let's take a look here. For example, we have Magento Catalog Helper Data class. Let's take a look into that class. So we have Helper Data class. Let's take a look into its constructor. It's a huge constructor, and we can see it has parameter called template filter model. Now this template filter model will have a type of string, and this string would be this text. There is another parameter called catalog session. Let's take a look into that. Where is catalog session? Here we have catalog session parameter, which is instance of a Magento Catalog Model Session object. And we can see that in this case it would get some other object instead. So using this argument tool, we can specify what exact parameter would be passed into the constructor arguments when object is instantiated. This is another very powerful technique. So in your code, you may change any object of any class with your custom implementation if you need to do so. And Magento follows dependency injection concept, which means that all classes that Magento use would come through its constructor. So it gives you huge power in customized Magento. And the last thing, which is also very important, is one particular case of arguments, which is array. So for some classes, they would have array argument. or argument of type array. And for such arguments, we can add items to that array. For example, we have a class Magento catalog, model, entity, product, attribute, design, options, container. Let's take a look into that class. Model, entity. Here we go, model, entity, attribute, design, options, container. Here we have a class. This class extends another class, which is EAV config, Magento EAV model source config. Let's take a look into that class. Here is Magento EAV model entity config, model entity attribute source config.php. So this class has a constructor of array of options, and so container class, which extends it, will also have a constructor with array of options. And now we can set items into that array, and we can do it from any module. So in your module, you can create the same declaration in your DI.XML. Those DI.XML would merge, and finally, this object would receive multiple elements in its option array. This is very common technique and very powerful technique, so it's used a lot in Magento, and it's very, very useful for customizations. Those three concepts of DI.XML, preference, virtual type, and arguments, are key of Magento dependency injection system, and it gives extreme flexibility and power for developers to create customizations. There are also another set of customizations that could be done with plugins, which we did not cover in this video, but it would be covered in another video.
See your course exercises guide for instructions on how to complete this exercise and the solution.